Okay, we are going to continue chapter 2, section 3 about energy. So based on the source of energy, we can divide energy into two categories. Renewable energy, gained from resources that are replenished by natural processes in a relatively short time compared with the human lifespan. Non-renewable energy or resources can be depleted and are not replenished by natural processes within human life scales. These are several numbers you needed to know. So the energy we used to survive, actually 99% comes from solar energy. And then when we mention this solar energy, we are also including wind energy, hydropower, and biomass because they are indirect solar energy. So only 1% the energy we need for survive coming from commercial energy. And then in this 1%, 87% of them are coming from fossil fuels. These are examples of fossil fuels. You have natural gas, coal, and then petroleum. And the energy based on their capacity to do work, we can divide them into high quality energy, which has high capacity to do work. They are more concentrated, such as high temperature heat, strong winds, and fossil fuels. We also have a lower quality energy. They have a low capacity to do work, and then they are dispersed. One example, think about right now, you and I disperse heat from our body. These are energy, but we are not able to use them to do anything. Low quality energy. So again, energy change are governed by the two laws we mentioned at the beginning. First law is the thermodynamics is energy is neither created nor destroyed. Don't stop here mentioning in physical and chemical changes. The second law of thermodynamics, energy always goes from a more useful to a less useful form when it changes from one form to another, in physical and chemical changes. So basically, an energy transformation occurs and results in increased disorder, less usable energy. And then one way to use energy is called energy conservation, energy saving. We can never recycle or reuse high quality energy to perform useful work. You need to remember this statement. And then the following numbers you also need to know. So scientists estimate that about 84% of the energy used in America is either unavoidably wasted because of the second law of thermodynamics during energy conversion. So this is about 41%. And then another 43% are unnecessarily wasted. Like when I turn on hot water, actually I don't need hot water. I leave the light on when I don't need light on. And then to improve energy efficiency is a great thing to use energy more wisely. For example, if we change the 5% incandescent light bulb to fluorescent or LED light, it make a big difference if everybody does that. So we are looking at the last section. This section has several terms that probably are new to you, so pay attention. It's talking about systems. Systems have inputs, flows, and outputs of matter and energy, and feedbacks to affect its own behavior. So a system is a set of components that interact in a regular way. Examples are parts of the human body, and then parts of the earth, and then parts of our economy. And the feedback are processes that increase or decrease the change in a system. So we will show you slides with examples. So here an example of a system with inputs and outputs. So any system always involve energy resource, matter resource, and information. And then the outcome is they produce some goods and then waste as a pollution and also just heat, waste heat. This all systems go through this process. So feedbacks, a positive feedback. So this one causes the system to change further in the same direction. So if the beginning direction is bad, and then the feedback would cause the bad condition become worse. However, a negative or corrective feedback loop, this one cause the change go into a different direction. So it's a balancing process. So one example is the forest experiment we talked about at the beginning of the core case study. So at the beginning, the bad or not good change is decreasing deforestation. Because of that, we have more erosion and nutrient loss. And then this causes more of the vegetation die out. And then you have more erosion, more energy loss. And then more trees die out. So this bad situation becomes worse and worse. So this one is called positive feedback loop. So enhance the beginning change, keep going. However, a negative feedback loop, this one is a balancing, correcting process. For example, for the thermal temperature you set, if you set it 70, when they reach this one, your furnace would stop. And then when the room cool down, and then the furnace will kick off. And then the whole process is a balancing situation. We want this one in the natural environment. However, many of them are positive feedback loops. Another two concept in this slide you need to know is called time delay. So the amount of time between the input to a system and then until you see the feedback happens. So there's a delay. You call this time delay. And then a tipping point, this one is thresh level. So the point at which a fundamental shift in the behavior of a system occurs. So in a sense, when you reach this tipping point, the system is not able to recover back. Just imagine if when you stretch a rubber band, and then you stretch, they would go back. You stretch, go back. But if you stretch really, really hard, you reach to a point that a rubber band will break off. So that point is called a tipping point. So we try to avoid tipping point in the natural system. And then one more important concept, this one you would see on your quiz, the first thing on your chapter 2 quiz, is a synergistic interaction or synergy. So this is a kind of a combined interaction, combination. You can think this way. So two or more processes combine in such a way that the combined effect is greater than the sum of their separate effects. So for example, if you have impact of a hurricane, it is bad. And then if you have impact from tsunami, it's bad. However, if you have these two at the same time, their impact is bigger than their separated effects you put together. Okay, like some of the medicine, you take them together, they got a really bad reaction. So in nature, this thing happens a lot. Okay. However, synergistic interaction can be good too. So when I work hard, you work hard, and then combined effect would be better than our individual result. They can be both. So this is a summary of chapter 2. So you cannot really throw anything away. This is, sometimes we will say just things to throw away. Why not? So according to the law of conservation of matter, no atoms are created or destroyed whenever matter undergoes a physical and chemical change. Thus, we cannot do away with matter. No matter what kind of pollution, we cannot do away with matter. We can only change it from one physical state or chemical form to another. So even when we burn garbage, we not really destroy them. They simply from solid become a more condensed solid, the ashes, and then become gas format. We are not really destroy anything. So we should be very careful with the items we use. And then the second one is about energy. You cannot get something for nothing. So according to the first law of thermodynamics, or the law of conservation of energy, these are the same thing with different names. Whenever energy is converted from one form to another in a physical or chemical change, no energy is created or destroyed. This means that in causing such changes, we cannot get more energy out than what we put in. And then, based on the second law of thermodynamics, we cannot break even. So whenever energy is converted from one form to another in a physical and a chemical change, we always end up with lower quality or less usable energy than we started with. So when we make energy conversion, the less step, the better. The more steps are involved, and then the more useful energy would be lost in the system. I believe this is the end of chapter 2, so I would stop here. Thank you for watching.